These are examples of sequences. We can have either an infinite sequence where the numbers will go on forever, or a finite sequence where this is the last term or the last number in that particular sequence. If we have a special sequence called an arithmetic sequence, it means that we're adding the same number to each term in order to get the next term in that sequence. So we can see in this sequence, we're adding 3 each time. That's what we call the common difference. The difference is common between every pair of terms that we pick. This particular one, we're adding -2 to each term in order to get the next term in that sequence. My first term can be written as t sub 1, so this little 1 needs to be written below the line. It's subscript. This is my second term, my third term, and so on. We separate each number with a comma, and we continue on until we get to our last term. This is also what we call the general term. This n represents the number of terms we have in that particular sequence. N is a natural number, so your positive integers, 1, 2, 3, etc., because you can't have part of a term. This happens to be a finite sequence, so this is the last term in that particular sequence. This is also called the general term. I can use a function to determine the value of that term. So for example, I can find the 5th term if n happens to be 5. I can find the 8th term if n happens to be 8, etc. So this is always going to be a natural number, and then depending on the sequence that we're given, we can come up with a function in order to determine that value. In an arithmetic sequence, we're adding the same number every time in order to determine what that next term is going to be. So in this particular one, I can see that I'm adding 3, adding 3, adding 3. Make sure you check every value. If it doesn't work every time, it's not an arithmetic sequence. We call that number that we're adding each time the common difference, and we use a d for a variable to represent it. So in this case, we have a common difference of 3. What's our common difference going to be in this next sequence? So you can see each time we're adding -2. So that becomes our common difference. So if you take a number and subtract the number ahead of it, you can always get that value. So 1 minus 3 is -2. 5 minus 2 is +3. So if I want to know what the value of the 10th term is in this sequence, I would continue to add -2 until I got to that value of the 10th term. Or if I wanted to find the value of the 50th term, I would continue to add -2 until I get to that value. But that's time consuming and awfully tedious. So let's look at a different way that we can speed up the process of generating those values. If we know that this is the first term, that is just the value of whatever that happens to be. If I take the second term in an arithmetic sequence, so for example, if we go back and look at this one, I know that the common difference is -2. What am I doing to get to this second term? Well, I'm starting with that first term and I'm adding on one common difference. So we can generate that second term by starting with term 1 and adding a common difference. What am I doing to get to the value of term 3? If we start with term 1, you can see that we're now adding 2 common differences. So I can find the value of term 3 by starting with term 1 and adding 2 common differences. To get the value of term 4, again, I'm starting at term 1, and now I'm adding 1, 2, 3 common differences. So we can find that value very quickly. So if we continue on with this pattern here, let's say all of a sudden I tell you that we have term 1 and we've added 9 common differences to it. What term would we be on? Well, hopefully you can see that this is now going to be the 10th term. And we can continue that process indefinitely until we get to this last term. So if I want to find the value of the last term or any term along that sequence, if you notice the pattern here, we're starting with term 1 and we're adding 1 less common difference compared to that term that we happen to be on. So we're on term 4, we had 3 common differences. We're on term 10, we had 9 common differences. So to find the value of any term along here, what we can do is start with term 1, and we're always adding 1 less common difference than the number of term that we happen to be on. So we can use this formula that will allow us to calculate that value of our general term. All right, so let's say we have a sequence and we want to determine the value of the 8th term. So I can see that we're going 4 plus 3 is 7, plus 3 is 10. The first thing you want to do is identify what is the common difference, what are we adding to get the next term, and then check to make sure that we are consistently adding that amount. So in this case, we are adding 3 each time. That makes it an arithmetic sequence. So I can continue that pattern. 10 plus 3 is going to give me a value of 13, and then add 3 more, 16, plus 3, plus 3, plus 3, and there is my 8th term. It has a value of 25. Well, this is a little time consuming, plus if we get a higher value of term, we're not going to want to do this every time. So let's see if we can speed this up. So using this formula, I'm looking for the 8th term. I'm going to start with term 1, which has a value of 4, and I'm going to add to it 7 common differences. One less common difference than the term we're on. 7 times 3 is 21, plus 4 quickly gives me the value of term 8. We can also go about this a different way and say term 3 is the last term that we were given. From term 3, there are going to be 1, 2, 3, 4, 5 common differences in order to get to term 8. So starting with term 3, add on 5 common differences of 3 each, and that's going to get us the value of term 8. So when you understand the concept of how arithmetic sequences work, there's different ways that you can go about getting the information needed. Let's try another example. So in this one, we're asked to find the 10th term as well as the general term for this sequence. So the first thing you want to do is figure out, is it an arithmetic sequence? So what are we adding each time to get to the next term? And if we're adding a consistent amount, it is arithmetic. So in this case, it is. So in order to find the 10th term, again, we can go about this a few different ways. The last term that we're given is the 4th term. So 1, 2, 3, 4. If we're at the 4th term, we're going to add 6 common differences in order to get to the 10th term. So we've already established that the common difference is -4. We're adding -4 each time. And so we can substitute those values in there and find the value of the 10th term. Or we can also use that formula to find the 10th term. So if I take this formula, we're starting with term 1, which is 14. We're now adding 1 less common difference than the term number. So we're adding 9 common differences of -4. And again, when we go ahead and work that out, we'll get the same value. Now, in terms of the general term or the nth term, we're going to substitute in here. So term 1 has a value of 14. We're looking for n, and because we have a variable in here, we're going to distribute that -4 into the bracket in order to simplify this. And then we can go ahead and combine our like terms together. And this would be the simplified form of the general term. And then you can even test this out. So we found previously the 10th term. If we put 10 in for n, 10 times -4 is -40, plus 18 is -22, so we know that this simplified general form is going to work for any given term in that sequence. In this question, we have a finite sequence, so we are given the last term. The first thing we want to do is check to see, is it arithmetic? So are we adding the same amount each time? So we can see -2 minus -5, that's going to be +3. 1 minus -2, that's going to be +3. So it is arithmetic based on the information we're given. So we can take that formula that we have, and we now know that the last term we have is that 103. So we can substitute that in, along with our first term is -5. And we're looking for n. That is the number of terms in that sequence, and we know the common difference is 3. So now what we're going to do again is distribute that 3 into the brackets, and when we do that, we will end up with this. We can go ahead and combine our like terms together, and then we're going to add 8 to each side to try to isolate n, and then we're going to divide out that 3, and when we do, we end up with n is 37. And then you can always substitute it back in and go -5 plus 37 minus 1 times 3 and check, do we end up with that 103 for the last term? Also remember that n has to be a natural number. So if you get an n value that's either a fraction or a decimal or a negative number, then somewhere in there you have a problem. In this next example, we're asked how many multiples of 5 are there between these two numbers. So a multiple of 5 is like 5, 10, 15, 20. We're skip counting by 5. So that 5 is my common difference. I'm looking for how many, so how many terms is going to be my n value. But my first term is not 11. 11 is not divisible by 5, so therefore 11 is not a multiple of 5, nor is 253. We have to be between those numbers, so the first number that's divisible by 5 between here is going to be 15. Now, if you're not sure how to get that, or if you have numbers that are quite large, we can always say, okay, take this 11, divide by 5, and we get 2.2. This is the low end of the sequence, so we need to round up, and we're going to go 3 times 5. That's the first multiple of 5 within here. The last term is going to be, and again, we can always take, if we're not sure, that 253 divided by 5, that's the multiple of 5, and we get 50.6. We have to round down so that we stay within that range, and when we do, so we take 50 times 5, we'll get 250. On the first term, you want to round up to get into this range. On the last term, you want to round down so that you don't go over. So round up to get in, round down to stay in. Make sure the first term is higher than that number, the last term is lower than that number, and then we can substitute into our formula. So we're going to start with the last term. This 250 is equal to the first term, that 15, plus n minus 1 common differences, and then go to simplify. So we're going to get rid of those brackets, combine our like terms, and then solve for n. And when we do, we end up with n is equal to 48. So there are 48 multiples of 5 between those two numbers. We're going to take a look at one last example. We're asked to do two things. Number one, we need to find the first term in this sequence. Number two, we need to find the general term for this sequence. So we're told that the 8th term is 166 and the 12th term is 130. So I've gone ahead and just drawn this out so we can see what's happening here. And there's two different ways that you could go about doing this. So the first thing is we can take a look at this and say, okay, let's pull out kind of a mini sequence here. So if I'm just looking at this piece, this is my first term, and then I'm adding 1, 2, 3, 4 common differences to get to what would be the 5th term. So we can see, okay, so my last term in that mini sequence is equal to my first term plus 4 common differences, and I now have one variable that I'm trying to solve for. So if I go ahead and simplify this, we can determine that the common difference is -9. So I'm subtracting 9, subtracting 9, subtracting 9, subtracting 9, and then we can continue down here where we would be adding 9, because we're going the other way. But a faster way of doing this is we can now say, okay, so if this is the last term in my sequence, we're looking for the first term because this is the 12th term. To get from the first term to the 12th term, we're adding on 11 common differences. So then we can go ahead and solve for that first term and we get the value of 229. So one way you can do this is to kind of pull out a mini sequence and then figure out how many common differences and work it out that way. Another way we can approach this is by setting up a system. So we can take the 8th term and say, okay, we got to the 8th term by starting at the first term and adding 7 common differences. We got to the 12th term by starting at the first term and adding 11 common differences. So now you can see that if we subtract these two values, we will be able to solve for that common difference. So my 8th term is 166. My 12th term is 130. I'm going to subtract those two equations, canceling out those first terms and allowing me to solve for the common difference. So you can see no matter how we go about this, our common difference is going to be -9. We can now substitute back into one of those equations in order to solve for the first term. So if I take the first one here, we're going to say 166 equals term 1 plus 7 common differences. Our common difference is -9. So now we can go ahead and solve that for the first term. We're now going to find the general term that represents this sequence. Now that we know the first term and the common difference, to get that general term, we're going to say the general term is the first term plus n minus 1 common differences. Distribute that -9 in, and then combine your like terms to get the general term. And then you can test this out. So let's solve for that first term here to see if we got the right one. So -9 times 1 plus 238, do we get 229? Try one of the ones that was given to us. So -9 times, this is the 12th term, plus 238, do we get 130? So you can check to make sure that everything works together.